Hey, are you a second semester senior who wants to get out of school but still has to learn how to find the surface area of a solid bounded by a region in the xy plane? Well, this is the video for you. You've already learned how to find the arc length of a function, find partial derivatives, and set up a double integral. Mix all three of those things and you get the formula for the area of a surface. It's not very difficult to understand the formula. All you gotta do is just visualize it. But if you want to see the proof, you can look at the textbook. And if you still don't understand it, dude, you're in multi. You're in the most advanced math class. Come on, bro. You gotta figure this out. I'm not even gonna explain it. I'm not gonna really read it. I'm just gonna disable the Ken Burns. Just look at the formula a minute. It's kind of just self-explanatory, dude. It's just like finding surface area, just like partial derivatives and partial derivative of x.
So we can do an example problem. Squared. We can find the surface area. Z equals x times y. It's inside x squared plus y squared equals 1. So I drew out the circle. It should be a circle, but it's a circle. And it has a radius of 1, obviously. And I'll write down the formula because you should know the formulas. Formula would be surface area equals double integral square root of 1 plus partial derivative of x squared plus the partial derivative of y squared dA. So now that we just wrote down the formula, first thing we want to do is find the bounds. So obviously, since we're in the rectangular coordinates, we'll use dy dx, and to find the bounds for dy first, we can solve for this, right? So we can put x on the other side, so 1 minus x squared. And if we get the square root on both sides, we'll get plus or minus square root of 1 minus x squared. So this is the bound. These are the bounds for y. So it's just going to be negative square root of 1 minus x squared to root 1 minus x squared. So that's the bound for y. And since if we look at the circle, since the bound is only for dx is going from negative 1 to 1, right? There's nothing else that it'll go past. It's only from here to here. We can just write down negative 1 to 1 because that's what the bounds are for dx. So this is going to be our bounds first. Oh crap! This is going to be our bounds for the surface area for here for this thing, man. For this thing, the partial derivative. This is our function right here. The partial derivative of x is just y, and the partial derivative of y is just x, right? All right. Now we can just plug the stuff all in, you know? So it's like the integral of, what was it again? Oh yeah, negative 1 to 1. And negative square root of 1 minus x squared to square root of 1 minus x squared, and square root of 1 plus x squared plus y squared, a little too long, dy dx. So this is the integral, and we just learned to set an integral up for the surface area. I don't want to find it, so you can use a calculator or something. I don't know. Bye-bye.